very important topic to talk about today, and that's about DC-DC chargers, but also the parameters of charging and how you go about getting the right profile for your battery. It could be AGM lead acid gel, or it could be lithium. People make the mistake in saying, well, it's lithium, it's X, and that's all chargers are the same. It doesn't. You'll see on the table here, I've got a range of DC chargers ranging from 5 amp to 20, 15s, 20 and 20. They all have different voltages that they supply to a charger. So they're voltage stabilizer or chargers. So these will take an input of say 9 to 36 volts, and they'll output, that one there is going to output 12.6. The 12.6 volt is what the V5 Nomad is designed for. It specifically takes 12.6 profile. So you don't take a 14.6 profile like we have here in the Matson, which is a 14.6, and then plug it into the V5. Because technically that Matson over there will charge at 14.6. That's the charge profile. So if it's basically like trying to overfill a bucket. You know, if it says it's like 1,000 litres, you try to put 1,200 litres in. This one here is a 20 amp, and that's a 14.6. That's a 15 amp, and that one's 12.6. These are both of these are 10 amp. Okay, they don't have VSRs, they don't have solar inputs, and these guys are 24 volt. That's a 24 volt, so that's 20 volt 10 amp, and that's a 24 volt 15 amp. So they all look the same in size, and they pretty much are, but it's all what's inside them. So one of the cool things to also get is get power analyzer. Our power analyzer will tell you between, say, the solar panel and the battery, the amount of current going in. The reason I need to talk about that is because people are still getting confused that the charge light on the Nomad, for example, on the V5 is going out when they've got a fridge charger, so it doesn't work when the fridge is on or the solar's not working. It's not the case. You've got to, talking about this time of the year, it might be a sunny day, but it's not necessarily getting the amount of PV going into the panel as it would be in the height of summer. So it might even be charging at 3 or 4 amp, and when you plug your fridge in, it draws 4 or 5 amp. If it draws more than's going in, that red light's going to go out. It doesn't mean it's not charging. If there's 4 amp going in but 4.5 going out, that means the battery's only losing 0.5 of an amp. It's as simple as that. So is there more going in than going out? If there's more going in, the red light's going to come on. The simplest thing to do to test it is just simply pull the load off and then watch the red light come on. If that's the case, it's working. It's working perfectly. It's just that between the solar, and you don't know what's up in the sky as far as the ozone, you don't know if there's any, dirty air around that's interfering with the amount of power that's coming through to the panel. I mean, there's a million variables that can be causing that fluctuation in the panel. Getting back to the DC though, it's very, very common for people to be plugging the DC in and overcharging the V5 specifically. Because what they're doing is they're getting themselves this one here is a 20 amp Matson, and that's going to charge at 20 amp. It might charge at 21 or 22. I know that these ones here, if you're ours, which are 20 amp, they'll charge about 21 or 22. So we never ever supply anything saying, look, go any higher than 20 for the V5. Because, for example, if you're using some 25 amp DC on the market, we do know some of the big name brands that have 25 amp DC, but if you check the specs on it, it will charge higher than 25. So it might charge at 26, 26.5. If your auto electrician says, no, that should be fine, then you need to get them to read the instructions for the product that they're using. If they don't understand it, they shouldn't be giving you advice. Because this is an electronic product, it's not just a battery, it has smarts in there. And the smarts are there to protect you and protect the battery. The V5, for example, it doesn't accept over 25 amp. If 25 amp charge gets put into it, what will happen is it will shut down, and the only way to reset it is put a load on it. And what happens, and this is happening quite often, is people are running a 25 amp DC, it's charging at 27 amp, and they have a fridge running on it. The fridge is cutting in, and then what's happening is the DC is overcharging, the BMS shuts down, and then the reset is because there's a draw on it, which is the fridge, it's over a couple of amp, that resets it. Then it oversupplies power again, it shuts down and just does cycle. It's been in our tutorials for years. It will eventually destroy that BMS, because the BMS is saying to me, you are trying to destroy me, so I'm not going to let you do it anymore. We thought you'd give it a couple of goes at it to say, look, you realise it's not working properly, stop it, read the manual, I'm putting too much charge in. So you need to understand what you're putting in there. So what will happen is if the battery's nearly full, you might have a 14.6 profile into a 12.6 product, like the Nomad V5, and it may survive. And the reason being is when the battery's full, it won't draw much from the DC because it's nearly full. It doesn't draw, say if it's a 20 amp DC charger, it doesn't draw 20 amp continually until it's full. It'll draw 20 amp when the battery's dead flat, and it'll start backing off as it comes full. The same if you've got a 25 amp DC charger. What will happen is if you've got away with it, you might even have a fridge on it, it stays full because it's always topped up and it's never had to draw that much, but you might have left it for a few weeks or 3 or 4 days with the fridge running, and then the battery's really flat, turn the car on, and then all of a sudden it's like turning the high flow on the diesel, and it pumps in as much as it can, and it will pull everything that's available to it. It'll just suck down everything like a sponge. That's when you have a problem, because now it's going to overcharge, because it's going to pull down that amperage now, and it's going to hit over 25. So if it says a 25 amp DC, it's most likely going to charge higher than that. You can ask an electrician and say, look, but I'm going to ask a specific question, will it charge higher than 25? And can we test it before you plug it into a Nomad V5? Because you can just use a multimeter or power analyzer. It'll tell you straight away. You'll see it straight away go to 27 amp. If it does that, the Nomad will be fine, and just say, well, it's not going to work for that unit. And you can use what's called a step down. So these are step up and step down. They take a voltage in of 9 to 36, for example, and turn it into, say, 12.6 volt, 14.6. And they might turn into, you have to remember that DCs also have 36 volt and 48 volt systems. If you plug your DC fridge, it's 1224, and you plug a 36 volt DC power solution into it, it's going to hurt the fridge. There's no doubt about it, because it's putting too much into there, and it will damage the fridge. And again, it's not following the specifications of the fridge. So with DC, it's very important to understand the lithium profile, or the profile of the battery. AGM lead acid gel, so they'll have their own specific profiles. And then you'll have lithium, it'll have LiFePO4, but it will have the actual voltage range. So some of the actual MPPTs, the controllers from the solar panel, you can dial them down, and you can dial them down to whatever voltage you want. And some of the higher end stuff like Victrons, you'll be able to do the same. The Nomad V5, it has an MPPT inside. The V6s don't, because they only take regulated only. The V5 has its own MPPT, and you can plug an unreg panel up to 200 watt into it, and it'll do it for you. The other issue people have with the V5 is it has a regulated input up to, and it has a maximum charge rate of 25 amp. It has a solar input as well, unregged. You can put a maximum of 10 amp in there. It's not a total 35. It's 25 amp max at any given time between the regulated and the unregulated port. So if you've got a 5 or 10 amp DC charger in the regulated input, and you've got 5 amp or 10 amp running from the solar, so you might have a 150, 160 watt panel, or even 200 watt panel, the maximum going to that unit is now 20 amp. Yes, that's okay. But you can't put 20 amp DC or 25 amp DC and then also plug the solar in on top of that, because it's exceeding it anyway. So you're going to exceed it. It's important to go through and read the instructions. The V5 instructions are on the website, and on technical specs. You'll be able to have a look at that and specifically look at it. It explains to you about when you're using a reg and unregulated together. It says just don't do it, but the fact is that you can't max more than 25 amp in there, and it's not 25 and a half, it's not 25 and a bit. And if a Lloyd electrician says, oh, it should be right, it's around 25, it's not. They're specifically designed with specific parameters, and they're designed electronically to protect the unit for specific reasons depending on its characteristics. So if you're unsure about anything, the best thing is don't ask the oil electrician. The best thing, if it's got to do with the Nomad product and you're not sure, don't take advice from an oil electrician. Send us an email and tell me what you've been told you can do, and we'll let you know if you can do it. So the simple thing is read the instructions, and if the oil electrician doesn't want to read the instructions, then don't let them install it, because it's something they're not used to, or if it's something they're not aware of. There are parameters. It's like every product you need to understand and read. We don't make, there's a fair million different chargers out there. We don't know what's inside them. We don't know what the compatibilities are, but we do know if you read the specifications and you do get the charge profile correct, that you won't have a problem. Okay, so again, if you've got a V5, make sure you charge it with the correct profile. Don't be charging at 14.6. And the other thing is, if you've got a V6, these are 14.6 profile, and then if you use a 12.6 DC charger or an AC DC charger, it's not going to charge. So we've had people who've moved up from V5 to V6, thought they can use the same charger, but you can't, because the maximum charge rate on the V5 and the AC DC is 12.6. The V6, which is the LiFePO4s, they'll take 14.6 profile, so it's not going to charge. It won't detect it and it won't charge. There's nothing wrong with either unit, it's not the right profile. So you have to look at the specific profiles of the DCs for the specific unit you've got, and also the chemistry for those units. So I hope that clears up DC-DC in general. And again, if you've got a DC-DC with solar input like these, then great, it'll do it all for you, but don't exceed whatever the max is. The V6's max and L series LifePower4's maximum 50 amp, which means don't put 80 amp in. It says 50 amp, keep to 50 or less. No reason not to be using a 20 or a 40, and you're safe, and you don't ever push things to the limit. The same with inverters. I could plug a 1500 watt inverter into the Nomad V5. I can't use 1500 watt because it's a 20 max output, so I can probably happily use 250 watt. So as long as I don't use any more than 250 watt on a 1500 watt inverter, it's okay. But people are plugging 1500 watt inverters in and think, oh, it's an inverter, I can just keep plugging what I like. You can't. Everything has a parameter, everything has limitations. And you need to read the instructions to make sure you stay within those limitations. And otherwise you can damage multiple components or products that you're currently using. So that's it in a nutshell. I thought I needed to cover that off because people are having questions on DC-DC or installing them without understanding what they actually do. And the other thing is make sure if it doesn't have a VSR like one of these, you have to put a VSR between the crank battery and the DC, which stops it from drawing from the crank when the car is off. So that's DC-DCs in a nutshell. If you've got any questions, please email us before you start doing anything yourself and before you start doing what you're told to do by an electrician, just to make sure